Okay, so we want to look at another U substitution problem. All right, so like always, we start out by asking ourselves, say if we were doing chain rule or taking a derivative, or does one part of that look like the inside of another function? So parentheses are usually a good clue, right? They group things together. It doesn't always have to be, but especially here where this is something squared. If my pen will wake up. There we go. So this is x to the 4th plus 13 quantity squared. So that kind of looks like it's the inside, right? It's something squared. So I'll try to make that my u. And then next step is take the derivative of u. So du dx is 4x to the 3rd. Derivative of 13 is 0 since it's a constant. Then we'll multiply both sides by dx because we're going to try to get that by itself. So cancel over here and then divide both sides by 4x to the 3rd. So now where there used to be a dx, we can replace it with this whole thing. And where there used to be a u, we can, or x to the 4th plus 13th, we can replace it, plus 13, we can replace it with u. And I'm trying to put kind of the replace stuff in blue just so we can see what we switched out there. So where we used to have a dx, we put something equal to dx, we substituted. And where we used to have x to the 4th plus 13th, we put our choice for u back in there. And then we'll see if anything cancels out. And so notice there's an x to the 3rd on the top and x to the 3rd on the bottom. And also for this 8 divided by 4, it looks like we have 8 divided by 4 is 2. So now we got something that started out being maybe a little bit 2 over u squared du of a jumbled mess, and we turned it into just one single term. It's all in terms of u, right? Everything matches. The du has to match. And it looks like we can use our normal rule for exponents, or right, our kind of power rule, our opposite of power rule. Then, I don't know about you guys, but first thing I like to do on those, it's way easier to see what you're doing if I write divided by u squared as times u to the negative 2, right? It means the reciprocal of, it's in the denominator. Because now when I think, hey, I have to add 1 to the exponent, it reminds me that my exponent's actually negative 2. So my derivative of u, or antiderivative of u to the negative 2 is u to the negative 1 over negative 1. And if we check the derivative of that going the other way would be u to the negative 2. So we didn't affect our constant, and then we have a plus c there. And so we're essentially done, except we don't want to give them their answer in terms of u if the question started out with x. So we'll put our choice for u back in there. And so u was x to the 4th plus 13. So we have, and if you want to do 2 divided by negative 1 is negative 2. Totally up to you at that point. So negative 2. This whole thing's to the negative 1, which means it's in the denominator. So if you want to put it x to the 4th plus 13 to the 1st, you don't even have to write to the 1st if you don't want to, plus c. So put our choice back for u in there. There's our final answer. And if you want to check, you can take the derivative of that using chain rule. You'll end up back where we started. You can almost kind of see the parts when you think about it going opposite, like in your answer. Here's the derivative of the outside and here's the derivative of the inside. So if you're going the other way to check and make sure that it worked.